Hello friends, in this video we will do the derivation of the mirror formula for the concave mirror. Mirror formula is 1 upon f equals to 1 upon v plus 1 upon u. Now this formula, what it does is it gives the relation between the focal length of the mirror, object distance and the image distance, where f is what? The focal length, u is the object distance and v is the distance from the pole of the mirror where the image is formed. Okay. Now, before we start with the derivation, we should know exactly how the image will be formed in this case. Now, as you can see in this figure, this is a concave mirror. AB is the object, C is the center of curvature, and F is the focal length. And obviously, P is the pole. Now, in order to trace the location of the image, we'll draw some standard ray diagrams. That is, we locate the location of the image of point A. For that, first we will draw a ray which is parallel to the principal axis, and after reflection from the mirror, it passes through the focus like this. Second standard ray which we will draw is the ray passing through the center of curvature, and after reflection it retraces its path back. Now as you can see, both these rays are meeting over here at this point. So this point basically suggests the location of the image of point A. So the image will be, if I draw a arrow perpendicular to the principal axis, I get this location of the image, which is A dash B dash. Okay. Now, apart from these two standard rays which we have drawn, we will draw one more ray, that is from point A, the ray which propagates and hits point P. After reflection, obviously this ray will also pass through point A dash. So now our ray diagram is complete, and now we move on to the derivation part. Now in this entire figure, you have to identify two sets of similar triangles. Now as I can see from this figure, I can say that first set is triangle ABC and triangle A dash B dash C. Look at these two triangles, ABC, A dash B dash C. Now see why they are similar? Because see, this is 90 degree, 90 degree. These are two vertically opposite angles. So obviously these two triangles are similar. Now if I use the properties of the similar triangle, I can write it over here. That is A dash B dash upon AB. The ratios of the sides A dash B dash upon AB equals to B dash C and CB. Means this ratio equals to this ratio of these two sides. Now I can also write this B dash C as PC minus PB dash, and BC can be written as PB minus PC. Okay, this step is, I think, is clear to all of you. And let's say this is equation number 1. Now I identify another set of similar triangles. Now if you see in this figure, if I take this triangle ABP and triangle A dash B dash P, these two triangles will be similar. That is, triangle ABP will be similar to triangle A dash B dash P. Now see how they are similar. This is 90, this angle is 90. This is angle of incidence, this is angle of reflection, so obviously angle I will be equal to angle R. And since the two angles are same, so obviously the third angle will also be same. So here again we get one set of similar triangle, which is ABP and A dash B dash P. And again I do the same thing which we did it for the first case. That is, I take the ratio of two sides A dash B dash upon AB. Now this will be equal to A dash B dash upon AB. Now this I can write it as B dash P upon BP. B dash P upon BP. Right? Now, say this is equation number 2. Now, if you see that the left hand side of both the equations are same, that is A dash B dash upon AB. So I can equate both the equations. So on equating equations 1 and 2, I get B dash P upon BP equals to PC minus PB dash upon PB minus PC. Now, if you see over here, now like coming back to the same figure, what about this PF? PF is F. I think this is quite light. I use another color, say fine. So what is this PF? PF is the focal length. What about this PB dash? This distance is V. What about this PC? This distance is R. And PB, this distance is U. Right? So now what I will do is, I will replace all these PC, PB, PB and all with the U, V, R or F. But when I substitute the values of U, V, R and F in this expression, I have to use sign convention. Right? So over here, first let's talk about the B dash P. Now what is B dash P? B dash P is nothing but V. And since we are traveling against the direction of the incident light, so here B dash P, I have to write it as minus V. Similarly, BP, again this will be U, but since I am traveling against the direction of the incident light, so this will be minus U. Similarly, PC will be minus R. PB dash, this will be minus V again. PB, this will be minus U. And PC, that is, this will be again minus R. Now, when you solve this and you use this expression, that is R equals to 2F, this expression is going to give you the result 1 upon F equals to 1 upon V plus 1 upon U, which is nothing but the mirror formula.